Hello, welcome back everybody. Here's another video of me learning or trying to learn systems programming through this fun language called Zig. For those of you who don't know, I have a couple of videos out. Essentially, I'm trying to learn the Zig programming language through Ziglings, which is a fun little course slash bunch of exercises created by Chris Bosch. And the idea is you go through by solving very tiny Zig programs, and over time you'll get a better foundational understanding of of the language, and thereby systems programming to an extent. Previously, we looked at some conditional branching statements, which is if and else. We also looked into looping constructs, while and for. Now let's dive right in and look at the next set of exercises. Okay, functions. Perfect. We've already seen the main function. Let's try and learn that in a bit more detail. Let's get started. So functions. We already created lots of functions called main. Yup. Now let's do something different. Let's create a function foo, and it takes an input n of unsigned integer of 8 bits. We also return an unsigned integer of 8 bits. All we're doing is we're taking an n and we're returning n plus 1. Yep, pretty straightforward. I believe most people watching this are trying to look up Zig would know what a function is, but in case on the off chance somebody is trying to use this video to follow along and maybe learn, function can be thought of as a named block of code. Anything that we want to try and reuse from different places, like for example, finding the factorial of a number, that can be a good function. Or function could be even something like adding two numbers. In this case, this function is to increment the number by 1. So almost anything that we can think of where we need to reuse something and it's performing a unit of work can be converted into a function. Perfect. So let's see. This is the syntax for a function in Zig. Pretty similar to most other languages. Let's see. The foo function takes a number n and returns a number that is larger by 1. Yep. Note the input parameter and the return type are both the same. They do not have to be the same. In this case, they happen to be the same. Cool. Let's look at a quick example. Import the standard function. We assign a constant answer, which is returned by this function called deep thought. The new function deep thought should return the number 42, and we just display pretty much answer to the ultimate question, and we're just displaying the constant. Cool. Looking at this, immediately we know this is a syntax error. VS Code is highlighting it for us. But just for the fun of it, again, so that we get into the habit of reading compiler errors, let's compile the function, and then we'll try and fix it. Oh, my bad. I forgot the run command. Cool. It's saying, hey, there's a syntax error here. What are you trying to do here? Go and fix it. We know from reading it above, we have the function keyword that's needed here, and we also need to return, we're returning 42. It can be U8, U16, U32, doesn't matter, but looking at the inferred type here, we know that it's expecting U8. Let me just read this as well. So we're just missing a couple of things. One thing we're not missing is the keyword pub, which is not needed here. Okay, I understand. So it's trying to say here we're using the word pub, which stands for public, but in this case we don't need it. Again, I did not it's asking us to guess it. I don't want to speak out of turn in case the next exercise explains it, but from an understanding from other languages, pub is essentially what we call an access modifier. So I'm thinking, since this particular functions within the same file in this case, I believe it's already accessible here. Now I know if this was like supposed to be available outside of whatever library we're building here or whatever program we're building here. In that case, we potentially would have to make it public so that it can be called from outside of this file. I know in other languages like object-oriented languages, you generally have public, private, protected, and all of them have different purposes. The main function being public makes sense. That is the entry point into your program. So you have to make it public so that the caller, which is the runtime, needs to execute it. So it makes sense for the main function, the entry point, to be public, because why would it be private? Because that's the thing that's running. But in the case of deep thought, it's not really needed here. But let's see, this will compile, but we'll also make it, yep, we clearly see the output's working, 42 is being returned, but there is no harm in making this public, I believe. It doesn't really matter unless the Zig compiler is going to scream at us for some reason. Yeah, doesn't really matter. It just, again, speaking from a C# perspective, again, we use private when we don't want certain functions to be accessible outside of the particular class or the namespace. This case, probably a reason similar. Let's trust the process. I'm sure the next exercise refers to it in some way. Okay, let's dig into this exercise. Now, let's create a function that takes a parameter. Here's an example that takes two parameters. As you can see, parameters are declared just like any other types. Yep, name and type. Makes sense. Pretty standard how we declare constants and variables too. Very, very similar. In this case, we can see that it's clearly accepting two arguments, parameters, and is returning void. Void, essentially, it's like a special keyword that says, hey, this function does not return anything. And generally, we use void in cases where it's just doing a simple database write or some operation of some sort, or if it's just printing something, displaying. Void is used to indicate that, hey, this function will run, but it's not going to return anything back to the caller of the function. Pretty straightforward, standard syntax. Cool. Now we're importing the standard function. We are we have the main function, which is public main. Its return type is void. Cool. And we're displaying all the powers of 2. And we have a function 2 to the, again, this function right here. This is what we'll have to fix, but essentially we can see we're passing the different powers that we want to be applied on 2, and we want the output of all of those inputs. Pretty standard, pretty straightforward. Let's try to understand it. Okay, please give this function the correct input parameters. You'll need to figure out the parameter name and type. We're expecting the output type has already been specified for you. Yep, makes sense. Unsigned integer, 32-bit, that's what it's expecting. And again, input, usually, since we already know here and I can already see it's only 1 to 4, let's just go with the smallest possible data type that satisfies it, and that'll be U8. I believe this will work, and all it's doing is it's calling in the standard library, calling in the math namespace library, whatever it's called, and then it's trying to compute the power. It's saying I return it in the type unsigned integer of 32 bits, and the base number is 2, and this would be the power. Cool, let's give this a quick run. Oh, file not found. Functions 2, my bad. Perfect, makes sense. 2 to the power 2 is 1, 2 to the power 2 is 4, 8, 16, and so on and so forth. Yep, makes perfect sense. I don't think there's much to dive into here. Pretty straightforward. Functions are just blocks of code that is generally written so that we want to reuse them. But the other purpose could also be, hey, we just want to group this piece of code and we want to separate out. Long-term functions do help with maintainability of code, provided they're used carefully and we're not overly abstracting them, because we're not nesting functions inside functions that kind of breaks the point of creating the function in the first place. But they are a good source of organizing the code base, and they serve multiple purposes of code maintainability and code reuse. Perfect. Now let's go on and see the quiz. Oh, these exercises seem to be straightforward and quick. Nice, can't complain there. Let's see if we can make use of some of the things we've learned so far. We'll create 2 functions, one that contains a for loop and one that contains a while loop. Both of these are simply labeled loop below. Okay. Importing the standard library, main function, we have an array of numbers of U16. There's a total of 4 elements, and I know from previous exercises we could have just done this, but in this case it's still explicitly written it completely fine. Nothing wrong there. And we have a function called print powers of 2, and it prints the powers of 2 for each of these. So these are the powers, and it'll compute the power of 2 for each of the powers passed. Perfect. And we are printing a new line after after all the stuff that's printed here in the same line, I believe. Cool. Okay, well, you won't see this every day. A function that takes an array with exactly 4 numbers. This is not how you would normally pass an array to the function. We'll learn about slices and pointers in a little while. For now, we're using what we know. Makes perfect sense. I am very excited to learn about pointers as well as slices, particularly pointers, because I have some knowledge of them through C, and I know from C that they are an amazing programming construct, but I believe they make it super easy for somebody who doesn't know everything, to dangerously write code, essentially. When one doesn't know enough, you start to write really, really bad code. I'll be honest, I am also trying to learn more and more about pointers, and Zig would be the perfect way to refresh my memory based on what I know from C. Cool. This function prints but does not return anything. Right off the bat, we know the return type is void. Not returning anything, void. The English word is very similar to what the English word means exactly what it says. Cool. Now we have loop and we have and. Right off the bat, looking at the syntax, we know that this is a syntax for a for loop. Let's write for, and immediately n now the compiler the LSP immediately knows, oh, n is an unsigned integer of 16 bits, because that's what we're passing, and we're printing each of that. Cool, that makes sense. Now let's come here. This function bears a striking resemblance to 2 to the, in the last exercise, but don't be fooled. This one does the math without the aid of the standard library. Ooh, this is interesting. This almost feels a little bit like lead code to an extent, because, oh, don't use the standard library, but recreate the standard library by yourself. I see what they're trying to do. They're trying to show us the usage of for loop and while loop. Highly inefficient program, because it's going to be an n square time complexity, but that's besides the point. We're learning the language, not fancy optimizations right away. Cool. Let's go ahead. In this case, we needed to return a value because we know it's displaying the value. Now, what value do we want it to return? We see n is u16, total is u16. That means what's going to be returned here? More than likely, it's going to be the total, right? Yep. It is going to be the total. If that's the case, let's put total here, and let's return the type u16, because that's the type for total. Okay, now we're doing the power of 2 right here. The power of 2, another power of 2 is nothing but the number of times the number must be multiplied by itself. A power of a number is essentially the number of times a number should be multiplied by itself. That's exactly what it's doing. The counter here, this case, the syntax is eerily similar to a while loop. What gave it off is the continue expression here, as well as the condition expression here. So we're doing it up until from n, which is the loop control variable, starting from 0, and we're doing it up to less than number. Say if this was 1, we would do less than equal to number. Doesn't matter for now. We'll start from 0. And we're computing the total, the power of 2 here. Perfect. Let's go ahead and try it out. And we have our output here. 2 to the power 5, 2 to the power 6, 7, and 8. And these are all correct values. Immediately 2 to the power 8, we've seen this multiple times. If this is right, 256, then the others are also essentially correct. Because the same code is running everything. Perfect. We got through those 3 exercises pretty fast. And I think we have a decent understanding what a function's all about, how to use them, the input parameters, the return type and values. We've seen all sorts of fundamental combinations. Looking at the time, it's okay, it's less than 20 minutes. Let me see. Maybe we can continue with another problem. Okay, let's resume our exercises. Let's take a look at the errors exercise. This would be an interesting and fascinating topic. Let's see. Believe it or not, sometimes things go wrong in program. Oh, 100% we can believe that. A whole lot of programming is about debugging, almost more so than new feature implementation. It's about knowing how to debug and knowing how to put systems in place to prevent errors that are highly likely to happen and preventing them from causing too much disruption. That's essentially how we build resilient systems. Cool. In Zig, an error is a value. Errors are named so we can identify things that can go wrong. Okay, interesting. In Zig, an error is a value. Errors are named so we can identify things that can go wrong. Cool. I don't see anything about exceptions, so errors. Okay. Errors are created in error sets, which are just a collection of named errors. Okay. So in Zig, error is a value type, kind of similar to Go, I believe. Maybe even Rust, but okay. Errors are value types. Now, errors are created in error sets, which are just a collection of named errors. Makes sense. And errors are obviously named so we can identify things correctly. We have the start of an error set, but we're missing the condition too small. Please add it where needed. Okay, so this is how we define a set. Similar to arrays, sets are another form of collection. And here we have named set of error. Ooh, now I understand what they mean. Error by itself is a sort of a type. Is that what they're trying to say? Error is, oh, it's a value. Okay. And what will be the type of this? Let's go and change this to too small. Okay, this is a comp time type. And error is, okay, I understand. Okay, I think I understand. Let's keep going. So we have the standard library imported here. We have the main function. We're looking at an array of numbers, and we're saying for each of the number, we'll print the number, and we'll call the number fail function that returns an error of some sort. Let's go to the number fail function. Notice how this function can return any member of the my number error set. Okay, we're just simulating errors here. We're saying if a number is greater than 4, we'll say it's too big. If it's less than 4, it'll say it's too small. And otherwise we'll return and say my number error dot 24. I see this dry programmer humor here. But okay, that makes sense. And let's look at this, and we'll say if the number error is number underscore error is equal to number error dot too big. Error is a value type, so whatever is returned here, we can, this is how we generally do standard programming syntax here. We're saying this itself is a new type we sort of created, and the error is the value. These are the possible values in this set. So the way we would reference too big is we would say my number error dot too big. That's how the comparison is happening. Makes sense. We're going to print greater than 4 with a dot, and we know this already. Since the other one is equal to 4, we're printing equals. All we're going to do here is we're going to say number error less is equal to my number error dot too small. Let's run the code. Pretty straightforward here. So it's essentially printing each of our value here, and we'll say the number 2 is less than 4, 3 is less than 4, 4 is equal to 4, and all the other numbers are greater than 4. Very straightforward. I think we got a good understanding of errors. I know we want to use this in real applications, and that's when we get a true feel for why an error is a value type. But right off the bat, I really like this. It's a set. It's very loosely related to this new C# thing that came out. That's going to come out in C# version 15 and .NET 11 later this year in November, I think. C# added the support for typed unions, and one of the good use cases for that is when we try to return is when we make network calls and we want to see whether the network call succeeded or it failed. It's sort of like a result type that we can build using that union. This is somewhat similar to that. Essentially, we're using the error, which is a value type, and we're defining the list of values. These are just names of type my number error type. That's essentially what's happening here, and this gives away right here because it's like a comp time thing. It's type. It's a new type that we just created. Makes perfect sense, but sometimes we need to go back, compare and contrast with the object-oriented mindset that's ingrained in my brain. Because I did start out with C, but the language that truly clicked for me was Java, and then that slowly cascaded into C Sharp, and on the side, JavaScript and Python were so sort of natural, and they just sort of got picked up. But to go back to the C way of thinking, it kind of makes sense why it's a value type, and this comparison makes sense, and I can definitely appreciate it now after writing REST APIs and microservices in C Sharp, why the semantics of how errors are handled and treating compile time errors is often more better than having runtime exceptions. Cool. Let me check the time. I think we're around the 25-minute mark. I want to try and keep these videos under 30 minutes because I feel like 30-minute chunks of study is relatively good. We want to go slow and steady because the goal isn't to just say we know a little bit of Zig, because I've been in that trap way too many times. I'm like, I looked at this new language, I read a whole bunch about it, and I sort of know enough about it, and let's move on to the next thing. We don't want to do that. The goal is to learn systems programming, and Zig is just the modern way that I want to use as a ladder to get into systems programming. So we'll take it slow. Let me just do one last exercise and we'll call it there. I'll call it there. But it's been a fun learning so far. Cool. Let's see. A common case for errors is a situation where we're expecting to have a value or something has gone wrong. Wait, let me read that again. A common case for errors is a situation where we're expecting to have a value or something has gone wrong. Yes, this is literally what I was trying to think about when I was saying C# and network calls. Yes, either there's a success value or there's a failure of some sort. Cool. So we have our text and we're trying to get the text. What happens if getText cannot find the file here? How do we express this in Zig? Zig lets us use what's called an error union. Oh, okay. Perfect. This is... Look at me, I was in the right track, which is a value which could either be a regular value or an error from a set. Cool. Var error, my error set is an exclamation mark text. I understand this right away. It's trying to say this particular variable will be assigned a value that's returned by getText. If the value exists, it's going to be text. If it does not exist, it's going to be an error set. And I believe the exclamation mark is identifying that. For now, let's just see if we can try and make an error union. Okay, perfect. Again, C# just added support. I think it'll be launched in November of 2026. I really appreciate it because up until this point we had to work around not having this in C#, but I know Go has optionals, which is quite similar, I believe, to what we're about to do. Cool. So we have the standard library, we have our error set, we're identifying it as error, and we have toSmall, which is again a value of type error, which is of type num error. Cool. Var my number is 5. Let me just say an unsigned integer of 8 bits, smallest number that satisfies it. Looks like my number will either need to store a number or an error. Can you set the type correctly above? Cool. It should either be, at this point it was just a number. Now we'll say it can either be a number or it can be my number error. Make sense? I'm taking the syntax exactly from here. We have a variable. This variable can be an error. We'll identify that first, or we'll put a exclamation mark in U8. Let's run this piece of code. I want to run the happy path now, and then we'll go back, undo what we just did, and try and run the error path. Perfect. I completed. So I compiled. So the function works. Let me try and do something. Let me undo the change we made. And let's run it. Be a syntax error. Perfect. Let me just put U8. Let me run it now. And this is what's going to be interesting. What is the compiler going to tell us now? Because we've put valid syntax here. However, it's valid at this point, but however, when we try and assign it an error, it'll blow up. But how will it express the mistake? Perfect. It's trying to say, hey buddy, you're saying this needs to be U8, but why are you assigning an error value here? This is incorrect. But the second we go ahead and add and say it can be either num error or it can be this type, it's going to compile and it's going to say perfect, it worked. Okay, I believe I have a very good appreciation for it. I do want to sort of continue and go to the next, but again, like I said, I want to cut this off at 30 minutes. That way it's a bite-sized chunk enough for me to implement, think about, come back the next day or whenever I go over it again to recollect what we just learned about. Again, this is very fun. Again, a huge shout out to the Ziglings project. A whole lot of effort has gone into it by Chris Bosch, and I think some other people also contribute to the repository by suggesting new exercises. I do want to say, if at all anybody wants to pick this up, highly recommend it. I know I've only done 22 exercises up until this video, but still, these 22 exercises have been a joy to work with. I appreciate that the exercise format is designed to be run locally and it's not like an online IDE. Not that that's bad, but it's just nicer to be able to compile the program, see the errors, team up with the compiler, and learn better. Again, a huge shout out to Chris Bosch for Ziglings exercises, and a huge shout out to the team over at Zig for building this wonderful language. So let's call it there. Yeah, that's all. See you all in the next video. Bye.